When we're talking about confidence intervals and we say we have a 95% confidence interval, we can think of that 95% as really telling us how often do the confidence intervals work and that they actually capture the population value we're hoping to capture in the interval. So in this example, we're going to illustrate that capture rate by looking at the Hollywood Movie 2E budget data in StatKey. We're going to generate 100 different samples of size 50. For every sample of size 50, we could get the sample mean, and that sample mean can then be used to construct a confidence interval. And what we're looking at then is out of those 100 different confidence intervals that we have, how many of them actually capture the original population mean we're hoping to capture. In practice, when you take a single sample and you find a confidence interval based off that sample, you don't know whether or not it's one that captures the population value or not. What we know is that the process works well and that 95% of the time we should have success in capturing what we're hoping to capture. So if we go to StatKey and we change our sample size to 50 and we look at 100 different samples, we'll generate 100 samples. Here are 100 X bars in this plot, and we know already, we've looked at this at the center where we want, so near the population mean here of 56.117. So the question is, if I take each of those X bars and I use it as the midpoint, adding and subtracting then some margin of error to get my confidence interval, how many of those confidence intervals actually capture the mean of 56.117. So there's a tab over on the right next to data plots for confidence intervals. And if we look at it in that simulation of 100, we see that 94 out of 100 did capture the population mean. And that's where that black bar is in the middle at mu. The other ones that are in red here are the ones that did not capture. So there's 6 out of 100. We're asked what would that value approach if we took more samples, because we only did 100. So if I simulated more and more and more and more, we expect that to approach that 95%. So the 95% is like a long-term rate of success that we actually capture the population value we're intending to. We're asked then for the ones that are in red that did not capture, where do the corresponding means tend to be? So if we look at this one here, which I just highlighted, notice that that mean is at 76.080. That corresponds to the dot that got highlighted at the very bottom right there. If I look at this one, 74.83, that's also off to the right. This one, also to the far right. So these 4 that are missing on the right side are the 4 data values to the right. And then the 2 over here on the left are the far ones. So the ones that end up missing the population mean are the sample means that are far to the left or the right of the true population mean. So what happens is just that sometimes by chance, the sample we select produces an X bar that is a little farther away from mu. And the interval that we get then does not capture the population mean. But most of the time, we see about 95% of the time, the process works and we get an interval that captures the population mean as we hope it would.